Hi everyone, welcome. Let's continue on question 4. I have already written down something for you. Okay, this is the information technology we're given of each field. Here I use capital letter A, B, C for each field. This is the capital one to differentiate from the little c I'm going to use for corn. Okay. All right, and I already draw the. I won't explain in detail, but again, if you have questions, come to me. We've done it several times in the previous exercise about how to draw the individual PPFs and compute the corresponding opportunity cost of corn as the absolute value of the slopes, right? So this one is 2. This one is, I made a mistake here. This is 3. It should have 3W. Okay, this is field B. This is field A, and this is field C. Okay. That's right, I think so. Yeah, and then the hard part becomes part B. How do we write the joint? Okay, so the first step, remember, is to add up the maximum potential output for each of the field to get the joint, right? You simply add up. So you add up these 3 numbers, 50, 33.3, with a dot, and then 50. So you'll get 133 here. Can you guys see it? I think you can, okay. 133.3 dot. Okay, and this one similarly will be adding the 3 numbers, this, and this. We will get 225. And then the question again becomes, if we go down from this point through the PPF, namely we start from a point where we all produce W, when everyone is produced W only, and we want to ask who, if we want some more C, who's going to produce first? And the rule of thumb is to compare who has the lowest opportunity cost of C in terms of W. And we already have the numbers here, so we can see that, this is one of W, okay? So 1/2 of W is smaller than 2W is smaller than 3W. So the order to produce C should be just corresponding field who has 1/2, C, right? Big C. And then we should have this one, A. And lastly, we'll have field B, okay? And so that's why the first slope you use when you go down here will be the slope of field C, right, which is -1/2. So it will be like this, okay? Relatively flat. And where do you stop? You stop at the maximum that field C can produce for C, right? For corn, which is 50. So you stop at 50. Maybe that's too much. Let me stop a little bit inside 50, and don't forget the slope, -1/2, and the corresponding value here, I think is 225 minus 25, right? So it's 200. And then you see that the next one is A, right? So you just start from this point, and draw the corresponding slope of A, -2. So this one is steeper. -2 until when? Right? Field B can, if field B only produces corn, he can produce 33.3, right? So this will add on to the original 50 we have from field C. So this number will be 50 plus 33.3. Wait, I'm sorry, I got it wrong. I'm using the slope of this, right? So I want to see what is the maximum output of field A if it only does corn. So the number is 50. So we add this 50 to the 50 we have here, which is 100. Okay, sorry about that. Which is 100. And then the slope, again, is from field A is -2. And then the third part, you can, it's just Oh, maybe that's, yeah, it's the difference is not that obvious here, but this one has a different slope. But maybe I should draw it better. Okay, here's the thing. I'll move the endpoint closer so that it looks steeper. This way. Oh, sorry. Okay, that's a cheat, I guess. Okay, I'll get points off on my graph on the exam. Okay, -3. Okay, so that's how you get the joint PPF. Remember, there are two kings, right? Because here we have three people here, or three fields. So it will be a piecewise linear with three pieces, and three pieces, of course, they will be 3 minus 1, which is 2 kings. And of course, as you see in the Mark's extended problem, there are 4 fields. So the joint PPF you end up with will have 3 kings. And of course, if you don't mind, you can add more and more and do the same, exactly the same process, and there will be n minus 1 kings. Okay, so let's go on to the later parts. Okay, I will erase this, but keep the top maybe. Okay, so now suppose field C can no longer produce wheat. Okay, I think that's the only restriction we have. Okay. Remember, I'll reproduce the graph we just had, something like this, right? C and W. So the difference is that first, this point is not 225 here, is not achievable or not feasible. Why? Because this point corresponds to when all 3 fields simultaneously all produce W, right? But now C cannot, field C cannot produce wheat, okay? Cannot produce W. So what is the maximum potential output for W after this law? It will be this thing here, right? 200, which is 225 minus 25. But of course, you can view it as the sum of only the largest possible wheat for A and B, which is 100 plus 100, which is also 200. Okay, it doesn't matter how you get this number. You can use both ways, either way. And so this part is go away. Okay, this part goes away because you can never achieve that. Not only this point, but also the whole line here disappears. It's removed from this whole upper part here is removed from your joint PPF. Because any point on here corresponds to a case when field C is still producing some amount of W, but any amount that is greater than 0 is prohibited. So you cannot do any point on these, right? So well, I will erase it. It's gone, okay? But you see that the rest you can still do, right? Because the rest, what about this point, right? We see that this point corresponds to, let's call it point M here. M corresponds to, suppose we go down this way, right? Hypothetically, everyone is producing wheat, and then M is when field C finished the transformation. So field C only produce C, produce corn. And that's okay because C cannot produce any W. So you see that in order to be efficient, given that field C cannot produce W, field C should use all its resources to produce C, right? Because remember that in order to be efficient, you cannot waste any resource you have. So all the points here, which some of you might include as in the PPF, is actually not. Those points, I'll write it in a dashed line to remind you that those points, you might think of them as on it, but it's actually not. It should be excluded because those points are achievable but not efficient. Okay, I should write it here. The dotted lines are okay, how to spell it? H-I-E-V, achievable, but not, I'll write inefficient, okay? Inefficient, it's inefficient. And of course, PPF, everything on the PPF should be efficient by definition. And if you're inefficient, you should be erased. Okay, that's part C. Let's go to part D, okay? Finally, the last part. And sorry in advance if I talk too slowly throughout the problems, but I want to add in every detail possible. Okay, so part D. We have improvement in C, okay? So a technology improvement in field C, okay? In field C. And this improves both numbers, right? Both corn and wheat production for this field. So now field C have, I'll just write it here, okay? Instead of 2 and 4, we have 1 and 2. You see that the ratio doesn't change, right? So which entails that the OC won't actually change, but something would definitely change, okay? So if you redraw the PPF using exactly the same steps we had before, so what changes is that this changes the individual PPF for C from, it shifts it out. Remember we did a similar exercise in the previous problem, right? It shifts out. Oh no, that problem we have a shift in because you have 120 acres of land down to 100. You have less resource, so you have an inward shift of your PPF. Now instead you have a technological improvement. Those are two different stuff, right? But the effect turns out to be the same. Is that your PPF gets a parallel shift depending on the direction depending on the specification of whether your technology improves or becomes worse, or your resource becomes more or less. Okay, so now C becomes this, right? It becomes 50 and 25 in terms of C and W. Don't forget the labels. And this is -1/2 still. And you can compare this, superimpose this graph with the previous one we have for part A. Oh, I'm sorry. This one is the previous one. What is the new one? The new one looks like something like, if you use 100 to divide by 1 and 2 respectively, you'll get 150. All right, so everything doubles. So it shifts out, but it's not drawn to scale, sorry. This should be 150. So it shifts out. So the intercept on both units are increased by, oh no, this increased by 50 and this increased by 25. The increase is different because the slope is not -1, it's -1/2. But anyway, it shifts out. And if you do the same process of combining this, but of course, now the order might change, right? Because the opportunity cost might change. But as you can see, if you compute the opportunity cost of C, OCC, for field C, it's still the same, right? It's still the same for C. It's still 1/2, right? It's still 1/2. Because we see that if you shift out, it's a parallel shift, so the slope doesn't change. It's still 1/2 W. Right? So the order is same as, as in part B, right? Where you draw the joint PPF. And then if you draw it, you follow the same order, but you just start from different places. You just start from different maximum potential output, because now those numbers change, right? From 50 to 100, or this is C, and then this jumps from 25 to 50. So when you add them up, when you add up the three maximum number for all the fields together to get the maximum joint, sorry, the number will differ. So it turns out to be 183.3 and 250. Okay. Remember before, what we have is 133.3 on this axis, on the C-axis, and 225 for the W-axis. Okay. Okay, and now I'll just draw this. The reasoning is exactly the same. Order is same. 100. Okay. Go a little bit further. Sorry, yeah, it's a little bit hard to draw sometimes. Okay, that looks not that bad. Okay, I'll give you the corresponding values of the kink points. 100, 150. Oh, sorry. This one is 100. This one is 200. Oh, it looks a little bit tilted. The axis. Okay. But that's how it is. First part, second part, third part. Okay, and we got the last part. I'll just write it here. Okay. So this is one. This is part 2. Does improvement in the water irrigation system have an effect on the joint PPF? Of course it has, right? So if you compare this graph with the previous graph you got in B, you see that something changes. But something doesn't change. What is that? It's the order. And the slopes, all three slopes doesn't change, right? Oh, sorry, I should. You see, I forget this sometimes. And it's always good to keep in mind of writing down the slopes. These three slopes are still the same, but the only difference is that the numbers here differ, right? The numbers here differ. And you will see that if I draw unfortunately I don't have another color, I'll just write it dashed lines. This one is the new one. If I draw the old one in it, it should look something like this. Oh, dash. I'm sorry, maybe that doesn't look well. Let me draw it again. I'll erase the slopes for a second and only draw the other graph in. It will look like this. Okay, yeah, it roughly looks like this. Again, the outside one is the real line, is the current one we have. Okay, after the improvement. This one is before the improvement. Okay, so you see that, as we said, they have the same slopes for each of the segment. So the shape doesn't change, but there's an outward shift of our PPF. So you see that the technology in field C only, right? There's no technology improvement in other two fields. It's only in field C, but it changes the whole ppm, right? Not the shape, but the location it is. So I should write outward shift from here to here. Okay, I think that's everything I have, and let me know if you have questions. Thank you guys.